Commercial Drones FM is brought to you by FLIR Delta. Delta is the definitive source for thermal drone knowledge, best practices, and training. Go to FLIR.com/Delta and get started now. Welcome to CommercialDrones.fm, the podcast that explores the commercial drone industry, the people who power it, and the concepts that drive it. I'm your host, Ian Smith. Hey everybody, and welcome to Commercial Drones FM. Ian Smith here, and I am with Patrick Thevoz. He is the CEO of Flyability, a Swiss company that makes drones. They're a drone manufacturer making some really cool indoor inspection-style drones. Welcome to the show, Patrick.
Hi, thanks for having me.
Thank you so much for being here. So first, I'm going to set the tone because we are in a place that has to be described. So we're in Chicago, Illinois. We're at Exponential, and we're in a grain room inside a brewery. What's the brewery called? Motor Row Brewing. We're in a grain room because Flyability has done their launch here for their newest product called Elios 2, which we're going to talk about. And this is the best place for us to record the podcast. It's dark, it's dingy, there's grain. We've got beers, though. Cheers, Patrick.
Cheers.
And we're going to drink them while we record this podcast. So again, thank you for having me. Was at the launch event last night for the Elios 2. Had a great time. Really cool, fascinating presentations that you guys had. So really want to focus on that. But before we get started on that and the products, tell us a little bit about yourself, Patrick. I mean, give us a little bit of your background. How did you get into creating a drone company and focusing on indoor inspections? What's the deal with that?
So yeah, originally I was an engineer by training. I've studied in Switzerland at EPFL, then studied for a little bit at UC Santa Barbara in the US. And after my master's, I really had this feeling that I wanted to understand how things were made, how things were brought to market, so kind of get a broader sense of what it takes to build a company. And that's not when I actually founded Flyability. Rather, I got into strategy consulting. I thought that was the best way to understand how things worked. So worked with a lot of blue chip companies, large companies launching new products, drugs, some very innovative product in existing industries. I did 4 years of that, got tired of it, traveled around the world, and then came the big questions about, what's next? Probably have to come home at some point. I was in Nepal, and that's when I actually connected with Adrian, who was doing his PhD in robotics. He's just finishing it. And I was like, hey, I'm probably going to come back to Europe at some point. Why don't we start a company together? I've got a lot of cool ideas, and let's try to do something. And I was like, yeah, totally. I'm just finishing my PhD. I've got a great prototype. It's got some initial traction. I think I'm onto something. Why don't you join me and let's work on it together? And that's exactly what happened. And we founded Flyability in 2014 as I was just coming from 1 year around the world.
That's awesome. So I'm going to hit the drum. So yeah, there's a drum set next to me. I just can't get over how funny this place we're recording is, but it's so perfect. It's super awesome, down to earth. We're both standing too, by the way. And thank you. Huge shout out to Mark for organizing this and getting us together. He's in the room too, observing diligently. So tell us just a little bit more about Flyability, though, the company. So how many employees do you guys have? You were founded in 2014. Do you guys have venture funding? I mean, what's the story kind of like with like the traction maybe that you guys have gotten over the years?
Right. It all started with this first video that was posted out of the research project during the PhD. Got a couple 100,000 views. People were all ecstatic about this idea of being able to fly drones indoors, having a drone that can tolerate collisions. And from there, the company grew pretty fast. So we got from those two founders to about 80 people today in about 4 years and a half. We indeed raised quite a bit of money. We've raised in total about $17 million. Yeah, now we have, robots all over the world, about 400 customers split over all the continents, mostly US, but we have customers in Greenland, in South Africa, all over the place.
And you mentioned just before when we were grabbing these beers downstairs that you guys are also participating in the Darpa challenge. Can you just tell us a little bit about that? What's going on there with the company?
Yeah, right. I mean, this is a really big deal for us because we're developing products really very much based on what the market traction is. But we also have, we have this DNA of engineers. We have probably about 80% of the people in the company are hardware engineers. So we have this urge to innovate, to develop cool stuff. So we were very proud to be selected as one of the Darpa Subterranean Challenge finalists, where it's about going in underground tunnels, caves, whether it's like man-made or natural environments like mines or caves, tunnels, whatever, and have autonomous drones being able to explore and map those very dangerous places. So we're both like working very pragmatically on today's market needs and going wild on some research and innovation projects on autonomous machines.
So you guys are... I'm going to go ahead. If there was if Las Vegas was taking bets on who's going to win that, I'm going to go ahead and go with you guys. I'm holding your new drone, the Elios 2, in my hand. It's really light. It's got this cage around it. I want to talk about this because this is the launch event last night. You've got people here, potential customers, existing customers, users from around the world, trying the new drone, the new prototype that you guys had sent out, but now it's no longer a prototype. But you even told me actually when we were on the way up here so we're at a brewery. So there's a big brewery, like the vats, like the big like containers, and like you use the drone even to go up in there. But for those who are not familiar, and I just have to like stand on a soapbox right now because the drone industry, as we call it or whatever, it's not just small outdoor drones. It's big drones, it's little drones, but there's also indoor drones. And like there's a lot of like interesting and extremely intriguing engineering problems with this, but at the same time you also get the nice, I guess, luxury of not having to, in terms of being indoor, follow a lot of regulations that you would otherwise potentially be stifled by. One of the things is a lot of times your operators and your customers are flying these out of line of sight, so like obviously that would never work in the US for a lot of things.
Right. We actually live in a very different world than most drone players. So as you said, regulations are very different. Because most of the times, as you're flying inside a factory, you're not under FAA or whatever national airspace regulations apply. If inside the boiler of a power plant you have an encounter with an airplane, you probably have, bigger problems than the drone flying inside it. So this is really good. Obviously, we have a lot of things we have to respect in terms of regulations. We usually have a spin with the health, safety, and environment teams when we come to a plant, but usually they're very, very welcoming because getting workers out of confined spaces is one of their holy grail. So when they see technologies that enable that, they're usually very happy and very supportive.
I love it. I love the juxtaposition. It's not talked about enough, yet it's a huge growing segment. And not just for your customers, which seem to be more industrial, but warehousing and all kinds of stuff. Even smaller drones that fit in the palm of your hand. So I'm holding the Elios 2. It's pretty light. I don't know what the weight is. You guys probably know. But I can hold it with one hand easily. So it's got a cage around it. The drone is kind of almost suspended in the middle of this like hexagonal cube cage. It's based off of the Elios 1, and you guys made a bunch of improvements, which I'll get into. But the drone, when it's sitting upright, actually, it looks like it's a flipped over drone. And the size of the drone, if you're familiar with drones, is like the size of like probably same rough dimensions of like an FPV racing drone. It's like, the actual fuselage itself is like that kind of size general. And then on the outside, there's a camera stuck on it that's gimbaled, and it has this just fascinating little like magnetic collision tolerant technology to it that I was fortunate enough to, if you can't tell, I'm really excited about this thing because you guys put in so much work. And again, it's not the beer talking from last night or today because we are still in the brewery, but you guys truly listened to your customers. It was so apparent last night that based on the improvements from Elios original to Elios 2, you truly listen to your customers. And we were just kind of chatting about that when we were walking up here. And you were saying that, we had to resist some of the kind of like the fancy new stuff, but really truly listening to what they wanted and putting that in the product. And so there are a few things I want to call out on this product that I'd love for you to kind of explain a little bit more that blew my mind yesterday. And one of them, like maybe we should start with probably like the first thing on this drone that you notice is this red gimbaled camera. So can you tell us about this and like the kind of like the collision tolerant aspect of
Right. So like we're very lucky to be pioneers in this indoor spaces. Back in when we started, if you're looking indoor drone on Google, you wouldn't find anything really. And now it's a thing. Now it's a segment. You see it on the market reports. I think that's a fairly unique thing to be able to pioneer a new industry. It also comes with a lot of challenges because you have no standards. You have to educate the market from scratch, and you have to understand things that become very obvious down the line, but initially nobody knows. For example, I think that the placement of this camera is something pretty different from what you will see on any other outdoor drone. Usually when you're flying outdoors, you are looking down. You're flying over the place of interest. You need the camera to have a fully unobstructed view going down. And that's pretty much the opposite when you're flying indoors. We're usually looking in front of us, for example, inspecting a welding or following some sort of beam, inspecting inside a stack in a plant. You would like to look around you as you go up or up, because a lot of times you're inspecting the roof. You're inspecting the railings at the top. You're inspecting the superheater of a power plant boiler. You almost never look down. Honestly, the only times we really look down is when we're just going back and finding our way out through the manhole of the confined space.
So fundamentally, yeah, if you put a piece of paper in front of me and said, hey, design an indoor drone, I would probably put the camera normally where most people would when they're designing a drone. And it's probably on the bottom of it somewhere, or maybe just on the front. But
right.
So if you're listening to this, I highly recommend go to the website and look up a picture of the Elios 2 so you can see, because there's a lot of stuff going on here. But this camera, it's not even touching the actual drone's fuselage, but actually technically is the cage part of the fuselage? Do you guys call it fuselage or what?
Honestly, I don't know what terms we're using anymore.
You're inventing the terms.
Exactly. I mean, on the previous version, we had a cage that was completely decoupled from the drone. So it basically prevented to put anything on the cage because it was rotating in all directions, and it was not linked electronically to the drone itself. What we have here is indeed the cage that is really fixed together with the drone, so it's like one single part, the drone and the cage around it.
Okay, good. I'm just I just wanted to say how much I love it again, but you guys really did a good job. So it's just inspiring. So the next thing I want to talk about, though, which totally blew my mind because I have no idea how the hell this works, is the lighting. So on the teasers, you guys had teasers and stuff. It's hey, the Elios 2, spotlight on Elios 2. And so there was a big emphasis on the teasers, on the posters on the wall that you guys made on the lighting system. So keep in mind, as you're listening to this drone is meant to go inside tight spaces where I guess humans would have to go normally or couldn't go in some cases and just never even knew. But the lighting is so important because you're going inside machinery and huge, big systems of crazy stuff that you have to have this light. And so one of the cool things that you said last night and showed in video was how the lighting is configured. These little LEDs stationed kind of oblique and on odd angles around the front of this camera on this drone. So just imagine dust flying up. Of course, you guys can say it much better than me, but if you shine a light right on that dust and you have a camera right behind it, you're going to see just a ton of dust particles. You guys somehow made something that eliminates that and kind of almost completely from the image. Tell us about that, because that's just, I want to know more.
Right. I guess that was one of the mistakes we made when we built our first product. Typically, you have a camera, you would put the lights in the same direction than the camera is looking, and that's where you would get the best intensity. But indeed, what we realized that a lot of places we go are incredibly dusty. Typically, we fly in cement factories. There are places called cyclones that are basically the worst environment you can think of. It's full of cement dust, and you need to run inspection all around the place. So basically you don't see anything. Same in a coal power plant boiler, for example, where you have those little coal dust that is very, very nasty. So we try to find a way to organize the light so that you don't have this direct lighting in front of the camera of the dust. So we worked a lot on placing the LEDs in a way that does prevent the reflection of the light on the dust particle to come back to the camera.
Because it just gets in your way if you're viewing the image.
Exactly.
It completely occludes what you're trying to look at.
And with this very particular LED placement, we're able to do that. But another really cool thing that we have enabled, and that is usually not something that you work on when you're doing drones, but more on inspection tools was we call Oblique Lighting, which is a way for us to recreate this movement that a lot of inspectors actually do, is like they take their torchlight and they apply it really parallel to the surface, and it really brings out all the shadows from the little holes, the pitting, the corrosion, and we're able to replicate this behavior with the lighting system that we have on the drone. And this is basically in this idea of having inspectors that are able to work as if they were up there under scaffolding or just climbing down a rope to inspect their facility, and to do the same thing, but just like from the safety of being sitting outside the tank in a very, very safe place.
And now, a quick word from our sponsors. Today's episode is brought to you by kittyhawk.io, the enterprise solution for drone operations management, available on the web, iOS, Android, and DJI's Crystal Sky. Operating a successful commercial drone program doesn't have to involve a ton of tools and time making them talk to each other. With Kitty Hawk, you can manage your aircraft, operators, and airspace all from a single unified platform. Managers can use Kitty Hawk to monitor their fleet, assign missions, and effortlessly track compliance. Your pilots fly in the Kitty Hawk app with safety and compliance settings that you customize based on your company's needs. There's even an API to make integrating Kitty Hawk into your workflows easy and automatic. Visit kittyhawk.io to learn more. Skywatch.ai is a leading drone safety and insurance solution, providing inclusive, flexible, and affordable coverage for commercial drone pilots, from single operators to enterprise users. Protect your business, drone, and equipment by obtaining Skywatch AI's liability and physical damage coverage, either with an hourly or a monthly plan. Skywatch AI's hourly plan allows you to get insurance on the spot for a specific job at an affordable price. The monthly plan lets you fly with peace of mind, with complete liability and physical damage coverage that you can change as needed. Additionally, as a safe pilot, you can save up to 50% on your premiums just by flying safely over time. Download the Skywatch.ai app through the App Store, Google Play, and the Drone Deploy app market, and get drone insurance that's tailored to your needs. Okay, back to the show. You know, I'm laughing because I'm thinking of like my wife on Instagram and like taking pictures, and it's all about the angles
Right.
for Instagram. And like really, like it's so crazy because what you guys did is so simple, but it solves these problems in such a cool way. So having the light not directly hitting the dust from behind the camera or in front of the camera eliminates the dust that you would see from the rotors kicking it all up in these dusty environments. And then also having the oblique angles, I guess I don't want to say exaggerates, but lets you see the like small pitting and cracks and stuff in like a surface that you would be you'd be looking at. So it's all about the angles that you guys figured out there. So I was just so impressed with the lighting system. It's not just, hey, we got bright lights. Like I don't care what the lumens are or whatever. I mean, you guys do and your customers do, but the fact that there's that much engineering thought behind it, and again, customer feedback and admitting like, hey, yeah, we didn't think about this maybe all the way through on the first version, but now we got it and we nailed it for you guys. The other thing is, and Mark, you were telling me about this, was that I mentioned earlier, like the drone, it looks, when it's sitting upright in its cage, kind of hexagonal sphere thing, the collision avoidance thing, the drone looks, normal drone, it would be upside down. But I'm sure that's a very purposeful design decision from an engineering standpoint. And it accomplishes a few things, I'm sure, that you can tell us about. But one of them was really cool, that the drone, if it flips over completely, like something that's happening inside the firmware and the way your motors work, you can completely reverse the thrust of the props if the drone flips all the way over, because you're going in these tiny environments that the drone could kind of like be turned around and it could catch on like an angle and
Right.
just flip around. So tell us a little bit about that.
I mean, that's indeed something that we're probably having to withstand more than any other drone as we're flying indoors. You have very, very strong disturbance. So typically, at the base of our technology, we were really looking at how insects actually work and operate. So an insect, it has really marvelous eyes that are amazing sensors to be able to find its way, understand where it is, etc. But it also is very, very tolerant to collisions. And we really believe at Flyability that both approaches need to coexist to have a reliable indoor flight. So the very first step that we had with Elios was to build this decoupled cage that was making the drone very much, foolproof. You can crash it against any wall, and you would just kind of like a housefly trapped inside a place. You would just roll on the window until you can find the exit, and just kind of randomly hit the place until you can find an opening. We solved the problem pretty differently on Elios 2. For a lot of reasons, it's much, much more convenient to have a drone that doesn't have a rotating cage around it, like abstraction of the image, the quality of the data that comes from the sensors. So what we actually did was work on the flight algorithms and on the motor controller. We redesigned the whole thing from the ground up to have incredibly fast and incredibly authoritative control over the drone.
This is not like a Pixhawk. Like, you guys made this whole thing. Like, it's complete from scratch.
The dynamics are really so different from what you would need for an outdoor drone. That we have built the autopilot, the motor controllers. I mean, all the code is very much customized to those needs. And this allows indeed the drone to react really fast, and the propellers also to reverse. So in the odd case where the drone would go through a particular nasty collision and find itself really upside down for some reason, we can make two propellers run in one direction, two propellers go in the other direction, and pretty much spin on itself without losing any altitude, so without causing a crash, whereas any other typical drone would end up just accelerating towards the ground when it's upside down, and that's the end of it, pretty much.
I don't know any other drone that has that capability. I guess a lot of them don't need it, but still very, very unique. What is the flight time on this?
So it's always a trade-off for us between the size of the drone and the flight time. So as you said, this one, it's a pretty small drone, actually. I mean, it's size of a small FPV racer, and it typically scales battery life and size scales pretty linearly. Our constraint for us is we need to enter inside confined spaces through manholes. Manholes, they're typically around 15 inches for the smallest ones, so that's our limit. And we design everything within this sort of sizing constraint. So what we managed to get was this one is about 11, 12 minutes of flight time. Depends a lot on the lighting you use and the flight conditions, etc. But this is the current flight time. The other difference we have with regards to outdoor drones is also that we don't usually go really far. I mean, you think of a tank, probably you would be at the entrance of the tank. Within 10 seconds, you are at the place of inspection. You don't need to, go for miles until you're like following a power line or getting to a field that you would need to map. So that leaves pretty much all of the flight time for the inspection itself. And then you just hot swap the batteries and fly again.
Well, I think, most drone operators this day and age too are used to relative sub-hour flight times. And so you get used to figuring out really quickly how to make the most of your flight time. But you guys have actually done the last kind of feature that really stuck out to me to make this a lot easier for the operator is, well, first of all, you're operating in a completely GPS denied environment. There's zero GPS signal. If you tried to get a GPS signal and make it correct, by the way, if you can hear the whining in the background, that's the Elios 2 downstairs in the brewery room flying around. So that's what that's been for the past couple of minutes, just so you know. So they're doing those demos here. But these drones are operating, well, there you go. We're in a building and the drone is flying around below us. And so just tell us a little bit about the systems that you guys use for the stabilization of the drone in order to not go completely crazy in a GPS completely denied environment. And also, there's a really cool feature that you guys highlighted last night that helps the operator if they're going down kind of a linear pipe or something inside of it to keep a uniform distance from the whole thing. And I guess I'm imagining it's computer vision based.
Yeah, so we have on this drone about 7 sensors all around it that are a mix of little cameras that are actually coupled with infrared lights. And those infrared lights, so basically allow the drone to use those sensors even in the darkest places. The cameras are looking at what we call the optical flow, so the way that the image moves, and this gives very important information on speed. And once you have the speed, you have a pretty good understanding of how you're moving with regards to your environment and what it would take to keep it stable. In addition to that, there's also lasers around the drone that allow to measure and sense the distance. So by looking at the optical flow, by knowing the distance, then you can, from those two informations, really understand and determine the speed of the drone itself.
And what I'm noticing, so we're still looking at the drone. It's sitting on the table in front of us. I'm noticing that there's this nice kind of heat sink on the back. And I am going to bet money that it's because there's so much processing power on board this sucker right here, making all those calculations like constantly, however many hundreds or thousands of times per second, that there's a lot of heat generated. And that's probably one of the things sucking down battery a little bit on this. What kind of onboard processing power do you guys have?
Actually, the heat thing here is mostly for the transmission systems and the power electronics. The part that is doing the processing of all the different sensors, so doing the sensor fusion between those sensors that we talked about and the different inertial sensors, so barometers, compass, accelerometers, gyroscopes, etc., is a little bit more towards the front. So I wouldn't be able to tell you really what exactly is the processing power and everything, but we're trying to build really small drones. Flight time, as we understand, is an issue, and we like to remain as light as possible. So we're really working on minimizing as much as possible the required processing power on board. And by using those sensors, we can do it on a pretty light platform. We don't need a huge platform running Linux computers with heat sinks and all of those things. But on a drone, you have something very, very convenient. You have a giant fan, so you can put a little heat sink and you take advantage of a propeller wash as an amazing cooling system.
Okay, but I lost my bet on the processor heat sink, but no worries. Nobody took me up on it, so that's fine. You guys also showed last night during the presentation the software. So you guys are also created your own software for flying the drone. I have yet to fly it myself. After this, I would love to go down and give it a shot down in inspecting a tank of that will hold some beer in the future, and make sure to give it my thumbs up and stamp of guarantee. But you guys made a huge point too that I thought is incredibly apt and extremely valid, not just for what your customers want, but for every customer that's buying a drone for their business, is that these inspectors are not pilots. And adding that to their skill set can be, well, it can waste a bunch of time, it's resources, it's a lot of training. It's not to say that they might not want to be, but in just thinking efficiency, they shouldn't have to be. And so you guys made a big effort of making this really easy to fly, your own custom flight controller. What is the interface with the human like?
Yeah, I mean, you nailed it. It's so important in order to scale in this business to not require drone pilots, because there's only a finite number of drone pilots, especially when you need to be able to act in emergency situations. A lot of the times when we're working at customers, there's a shutdown. It's not always planned, and the inspection needs to take place now. So we really need to train the people who are on the field or the inspection companies that are trained and that are on call for this particular plant. So in order to scale really fast, we need those things to be incredibly intuitive. And our customers, again, are not drone pilots. They're inspectors. I mean, a lot of our customers, it's the only drone that they have ever flown and that they will probably ever fly, because they would be completely incapable of operating a DJI drone outdoors. The fact that you can tolerate any collision makes you feel incredibly safe.
I can't wait.
What can happen? Just bump on a wall. That's the worst case scenario. And you're like, okay, yeah, I was going right, I wanted to go left, and then you're back to flying again. So what we did on this one was take advantage of all those sensors that we've discussed to basically make it, first of all, incredibly stable. So if you don't touch the controls, it remains exactly where it was. You don't need to compensate for when you have wind. So you would think, okay, you're indoors, you don't have wind. Well, actually, there's a lot of wind indoors, a lot of drafts, in a mine. Sometimes you have huge currents. And this is also another case for having a protective cage, because those things are sometimes pretty unpredictable. And if you don't have a mechanical system that makes sure the drone remains safe when it's projected very fast against the rocks, you really want this protective cage in those cases that happen pretty frequently. So by using those sensors, it compensates these effects, make sure that whatever happens, you remain where you are. We have a feature called distance lock that we use a lot for inspections of 2D kind of structures, where you can just remain in front of the object of inspection. So typically, you can think of a tank where you would need to inspect the welding around the tank. Just stay in front of it, say distance lock. just press a little button. It says, okay, the object is like about 40 centimeters, it locks a distance, and you can just move around very easily. The drone automatically adjusts to remain at the same distance, which is really important because the distance defines the resolution that you have.
Consistency
on,
of the data.
Yeah, exactly, on what you're inspecting.
So that actually brings me, I mean, coming to a close here, because I could just talk about this thing all day and all the different improvements and cool, like, just features you guys have put in. The data. All these freaking cool things that we've talked about, it's the means to the end. The data is what the customer cares about. They don't necessarily care about like all this like fancy stuff that you guys have done. It's just like, we need to easily get it. It needs to be cheaper and it needs to improve our operation and we will just buy them. Like, I mean, this is the goal, I think, for everybody here. Everyone's happy. So the data, last night it looked like, so you guys also do photogrammetry. So I don't come from a photogrammetry background, but I worked heavily with customers who wanted to use it and with photogrammetric algorithms, semi behind the scenes, not programming it or anything like that, but just working with people to enable them to do it. And all of it was aerial, outdoor, with GPS, most of the time a decent GPS signal, and getting huge photos. But again, it's all about scale. So you don't really need these big photos that take over acres. Like when you create a 3D model of an area, it doesn't matter how big it is or how small it is. It's just taking the data from the camera sensor. So your customers are using these for photogrammetry as well, indoor, like modeling, 3D modeling, like their assets and infrastructure from the inside?
Right. There's several very interesting use cases. So first of all, photogrammetry is an incredible tool to organize your data. Because, I mean, if you've run like tens of flights and a huge asset, you need to go through hours of video footage, and it can be very difficult to actually remember where each flight was taken. So we did a lot of steps on our software so that there's a naming structure. The pilot has to input where he's taking the flight and document all this. So when he plugs the drone to the computer, all this data is fed back to him. But photogrammetry can make it even easier because by building a 3D model, you're actually understanding where each of the picture were taken. So in the end of the day, you have a 3D model that really doesn't have to be perfect. You're not looking at the accuracy of the model in this particular use case. You're just looking at mapping the images where they were taken, so you can then just click on a point, you see all the different angles that this particular object was photographed from, and your data is organized. And you go from a video to a 3D model. You can think of countless examples where this is a game changer. Then sometimes you want to also have a 3D model to do some measurements. So natively on Elios, you can do 2D measurements. So basically, if you're in front of an object, you don't need to build a 3D model. It will understand what's the distance between the drone and the place, understand the angle, and be able to compute a measurement that can allow you to measure a crack or things like that. But you can also want to build a local 3D model. It can be of a small part. I mean, it's a part that seems broken when you want to make measurements. And then you can run a very local photogrammetric model to do that.
Wow. I should stop myself short because this is just something, again, 99% of the conversations we have are about outdoor, aerial, under the sky, GPS, blah, 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 photogrammetry of stuff. It's just like indoor. Anyways, it's just the nerd in me is kind of geeking out. So how much does this thing cost? What do you guys, roughly as it stands, like what can we expect? Like, is there a range you can give us or some type of information on the ballpark cost of one of these units of the Elios 2?
Yeah, at launch, this Elios 2 is going to be retailing for about 32,000 Swiss francs. So that's roughly the same in US dollars. So this is the initial price. It includes 1 day of training, all the accessories, batteries, casings that you need to get this to fly.
And what I heard, though, was that, like, and just kind of to wrap things up, is that even though the cost, like, obviously that was a leading question because I knew what you were going to say from last night, from the event. But so you guys had a bunch of customers come up at the end and kind of give some testimonials at the event. And the savings is ridiculous. There was like what was the company?
We had Exelon, we had Dow Chemicals, and we had Cyberhawk presenting at our event. Great companies that have flown like so much with our product. So, the savings, and this is also probably a really good concluding remark, looking at where the market is. And I'm insisting that for now, we're really still talking to early innovators, to this little few percent of the market that are true believers in new technologies, that are ready to spend time to engage with companies like us and be the trailblazers. This is just the beginning, and most of the market, even the early adopters, the early majority, is not yet using those type of products. And this is what we're expecting to change with this so easy to use indoor drone that is Elios 2. So right now, those very early adopters, either they're incredibly visionary, geeky, or whatever, or they have very big problems. So right now we're tackling companies that have huge problems, that have problems that cost millions. Like typically in the US, we are covering almost half of the nuclear power plants with our products. So there's one Elios in one out of two US nuclear power plants. It's because it's really expensive when you have a problem there. You put workers at a high risk. So, they're exposed to radiation, low doses of radiation. There's like very strong regulations, but exposing someone to radiation has a cost that can be computed in monetary value. And then often, if you want to reduce this, you need to reduce the output of the power plant. And this is incredibly costly as well. So you just turn it down a little bit, do your inspection, turn it back up. You waste $500,000 by doing this little step down, step up thing. So by using the drone, you can, over one single flight, save $500,000 basically in some cases. But those are extreme cases, and there's only so many nuclear power plants on the planet. So those things are amazing because it allows us to grow, to scale up at those customers that have expensive assets, so nuclear power plants, but basically any type of thermal power plants, refineries, chemical plants. All those things are really expensive assets that have big problems, where we can have a ROI that would justify a fleet of 100 of those things over a single weekend of inspection. That's not where the market is going to go down the line, looking at more like lower value but higher volume applications.
Whoa. Okay. Well, got to cut it short here, but if you're like me, I'm going to go to the website. I'm going to do what I'm telling everyone else to do right now. If you're interested in learning more about flyability in the Elios 2, go to flyability.com and check out the website there. I think the URL for just the Elios 2, flyability.com. If you want to go directly to the Elios 2 page, flyability.com/Elios-2. And then you'll land directly on the landing page for Elios 2. You just heard from Patrick Thevoz. He is the CEO of Flyability, co-founder of Flyability, and thank you so much for being here. Really fascinating stuff. Best of luck for the future. We'll be watching out for you guys.
Thank you so much.
Thank you. All right, everyone. We're going to turn off the mics. Cheers.
Commercial Drones FM is supported by MicaSense. MicaSense develops drone-based sensors for agriculture. With hundreds of research publications, dozens of case studies, and customers in over 75 countries, MicaSense sensors are proven to increase yield and save your customers money. For more information on what a MicaSense sensor can help you achieve, visit micasense.com.